Hi, I'm Doris Lee and I'm a product manager at Snowflake. In this video, you'll learn about what Snowpark Pandas is and the benefits of using it. Then we'll be showing a quick example of financial time series data analysis using Snowpark Pandas. Snowpark Pandas is an extension of the Snowpark API that lets you work with your familiar Pandas API for flexible data transformation, with the compute pushed down and running scalably and securely directly in Snowflake. So what are some of the benefits in using the Snowpark Pandas API? So it's well known that Pandas doesn't work well on large data sets. It's single-threaded, so things can get really slow when you operate on data at scale. What's worse is that you can only work on data that fits into your memory, so the moment you exceed that, you start to run into these out-of-memory issues. With Snowpark Pandas, you can continue to work in Python by writing pandas code, and we take your code and automatically transpile it to run on Snowflake, so that you get the benefits of distributed pandas at scale without having to worry about managing or tuning your compute infrastructure, so you can seamlessly take your pandas code from prototype to production. Second, pandas operate on your data in memory, so it requires that you pull your data out of Snowflake, which can lead to security concerns when your data scientist needs to pull sensitive data onto their local machines or laptops to do their analysis with pandas. With Snowpark Pandas, we generate the underlying SQL queries that are executed directly in Snowflake, so that your data never has to leave the warehouse. Organizations inherit the security and governance that is all backed by Snowflake. One of the most common things that we hear from customers is that they often need to rewrite their Pandas code into Snowpark or Spark in order to work on larger scale data in production. This involves substantial amount of developer time and hand optimization and rewriting. So with the Snowpark Pandas API, there's no need to rewrite your Pandas code. Developers can leverage their familiar Pandas API, freeing them up to focus on optimizing for business outcomes and putting more pipelines in production. Okay, so enough talking in the abstract. Let's take a look at a demo to look at some of the tangible benefits of Snowpark Pandas for financial time series analysis.
Okay, so here you can see that I have my Snowflake notebook open. And in order to use Snowpark Pandas, we first have to add some packages. So we're going to add the modin package. And you also need the Snowpark Python package. But because we're in a Snowflake notebook environment, every notebook already comes with Snowpark Python installed. So we don't have to add that into the packages list. So now that we have our packages updated successfully, I'm going to run this import statement. And these import statement essentially is importing the Snowpark Pandas plugin for Modin. And Modin is the open source library that Snowpark Pandas is built on top of. Now next, what we're going to do is we're going to create a Snowpark session. And one of the things I love about notebooks is that you can use this get active session command to essentially get your Snowpark session. So if you've ever tried to create a Snowpark session from a local development environment, you'll notice that you'll have to either put in your authentication information or username and password or things like that to be able to establish that Snowflake connection. But within the notebook context, this is much easier because we can use this get active session information. The notebook will automatically retrieve that information because you're already logged into Snowsite. Now, the next thing I want to do is I want to read some data from my Snowflake table. And so in order to do this, I can use this pd.snowflake command, and then it's reading from this table. And this is essentially a financial time series data set that I've downloaded from the Snowflake marketplace. And so it has around 68 million rows, and it takes about 9 seconds for us to read this table. Now, the next thing I want to show you is how would you do this pd.read_snowflake, or how would you read a table into something like a pandas data frame if you weren't using Snowpark Pandas. Let's take a look at this approach. This command is going to take a while to run, so I'm going to first explain what's happening here. So the way that I can read data from Snowflake into a vanilla sort of pandas data frame is by first creating a session connection and a cursor, and then I can execute a SQL statement. So the SQL statement is just a simple select star query. And so this itself doesn't take a whole lot of time. The command that is actually really slow and is the IO bottleneck is this cursor.fetchPandasAll command. And what this is actually doing is it's taking data out of Snowflake and then fetching all of that result from your SQL result set and then putting it into a pandas data frame. So you could imagine how this process essentially is the IO bottleneck, right? Because you're taking data out of Snowflake and then putting it in memory into pandas data frame. This is going to take a while, so we'll let this run for a little bit. Okay, so we can see now that the cell has finally finished completing its execution. This actually took around almost 3 minutes. It's 2 minutes and 51 seconds, 170 seconds total. And so this is a massive difference with respect to the 9 seconds that it took for us to load in this data with Snowpark Pandas. Now that we have a Snowpark Pandas data frame, I can do things like inspect the first 5 rows of the data. So here I'm essentially calling df.head to take a look at the first 5 rows of this data set. And then I can use Streamlit to print out a nice sort of data frame display and take a look at the data.
So how are we getting to this level of speed up when processing such a large dataset? As a glimpse to what we're doing underneath the hood, given this pandas query that we've written, Snowpark Pandas transpiled this query down to SQL and run it on the Snowflake engine.
The next thing I can do is I can use the Pandas API to filter the data. So here I'm looking at stocks that are listed on this New York Stock Exchange. So where the primary exchange code equals to New York NYS. And this took about 1.2 seconds for the filtering to be done. This is what the filtered dataset looks like. Now I can also apply multiple filters. For example, here I'm interested in these 3 tickers, Google, Microsoft, and Snowflake. And then I'm going to take a look at the pre-market open prices for these 3 stocks. So you can again see the filtered data frame, and then took about less than a second for this filter to be done. Now you'll notice if you're a pandas enthusiast like me that all this filtering and these data transformation that I'll be showing as part of this notebook is going to be all done with the same API and syntax as what you would do if you were working with regular pandas. So that's one of the value propositions for Snowpark Pandas is we let you keep the same API while we essentially are pushing down a lot of the compute to the Snowflake side so that you can work on data at scale. The next thing I want to do is I want to do some reshaping of my data. And I can do that through a pivot table. So you can see that essentially the pivot table takes this index, ticker, and date, and then it's fetching all the values column. And so I'll just show you the original table. The original table had this values column, and then with the specified index and columns, this pivot table essentially takes all of the values and then puts it in this pivoted table. Now I can also do other types of data transformation. So in this case, I'm working with the time series data. And when you're working with time series data, you often have to do resampling or taking a look at the values of a particular time series within a specific window. Here, I use a 91-day window, which corresponds to a quarterly window. And then I'm going to take the minimum. So essentially, I'm looking at the quarterly low of the Google stock. And this resampling took about 1.6 seconds. And this is what the resampled data look like. So for every quarter, I'm taking the mins. So this is the min across a 91-day window. And then I can even do things like diff. So I can take this series and then essentially doing a diff across each of these time windows. And then this is what the diff sort of series look like. So you could see this is essentially the quarter-to-quarter fluctuation when you use Pandas Difference API.
Now we want to apply the absolute value square root on each value in the series. Snowpark Pandas supports apply, which applies some arbitrary user-defined Python function along a particular axis of the data frame or series.
I showed you a lot of examples of how you can use the Pandas API to work with and transform your data. Now, one of the cool things I wanted to show you is how we do the apply functionality. In this case, I recall that I have my quarter load. This is the series. And then let's say that I want to apply the absolute value square root of these values. So again, this is what the series look like. There's some negative value because when you're taking the difference, it could be positive or a negative. I'm going to take the absolute value of this and then take the square root of that. And so I can do that with the pandas apply function. So the pandas apply function, what it's essentially doing is it's applying this lambda function. And then you can see that I'm using numpy, getting the absolute square root value for every single row. And then I'm also going to drop an a because there's a null value that is in there.
What we're doing here is that the Python function, which is shown as the lambda here, is serialized into Python bytecode, and we're running this as a UDF inside Snowpark's Python Secure Sandbox runtime environment. Snowpark's Python runtime environment is seamlessly integrated with the Anaconda package manager so that users can leverage their favorite third-party library packages such as NumPy for flexible data transformation within their data frame apply. So the TLDR here is that users are writing their Python pandas code and Snowpark handles the magic of compiling it down and running it in the Snowflake backend.
And then this is all running in Snowflake, and we're applying all of that to this pandas series object. So this is what the resulting data looks like. You can see that this is the absolute square root value of the series that we had up here.
To recap, in this video, we learned about how Snowpark Pandas lets you leverage the Pandas API with the compute pushdown and running scalably and securely directly in Snowflake. We saw a demo of how Snowpark Pandas is used to analyze a Snowflake table with more than 6 million rows of a financial time series dataset. We're able to flexibly transform our data to filter, reshape, and resample our data, all using the same syntax as you would with the Pandas API. Want to learn more about Snowpark Pandas? Check out the links below to try the demo that we showed here on your own and learn more. And don't forget to subscribe to our Snowflake Developers channel for the latest videos designed to level up your Snowflake skills. See you in the next video.